Hello everyone, I am Professor Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering from Sai Vidya Institute of Technology. I am teaching Basic Electrical Engineering subject for first year students. In this session, I am teaching root mean square value of an alternating quantity. Root mean square value is defined as the heat produced by an element when connected to AC or DC. It is the square root of the mean square value of current. Is called as root mean square value. So in this video, I am going to derive an expression for the alternating quantity, that is the current. I'm going to calculate the RMS value of the current. So let us consider a waveform. You can see here, this is a current waveform which is given by I is equal to Im sin theta, where I is the instantaneous value, Im is the maximum value, and sin theta, because it is a sinusoidal waveform, it is sine, and theta is the angle between the conductor and the magnetic field. So let us see how to obtain the square of it. So all of you know, if I is Im sin theta, square of the current is I squared is equal to Im squared sin squared theta. We can write cos 2 theta as 1 minus 2 sin squared theta. So 2 sin squared theta is 1 minus cos 2 theta. So sin squared theta is 1 minus cos 2 theta divided by 2. So I write it as IRMS is equal to square root of 1 by pi. I'm taking 1 half cycle. So 0 to pi is taken as 1 half cycle. So I am taking the lower limit as 0 and upper limit as pi, and I'm considering the square of the current. So it is I squared d omega t or d theta, because theta is equal to omega t. Now I say over here as I squared, I'll replace I squared by Im squared sin squared theta. And we know if I take Im squared outside, so I get Im squared by pi, 0 to pi sin squared theta d theta. Sin squared theta can be written as 1 minus cos 2 theta divided by 2. So I divide the terms 1 by 2 d theta into cos 2 theta divided by 2 d theta. So I get this in this way. So integration of d theta is theta. So I got this as Im squared by 2 pi outside. Integration of d theta is taken as theta, and I'll write 1 by 2 as it is. Integration of cos 2 theta is sin 2 theta divided by 2. So sin 2 theta divided by 2. I replace theta by upper limit minus lower limit. So in the place of theta, pi minus 0 is pi. I write it as pi minus 0. The second term vanishes because we all know sin 2 pi is 0, sin 0 is also 0, sin 0 by 0, 0 minus 0 is nothing but 0. So we get this as Im squared divided by 2 pi into pi. Pi and pi get cancelled, so you get it as Im squared by 2. Im squared by 2 is I squared RMS. If I take square root on both the sides, I get Im by root 2. 1 by root 2 can be written as 0.707 times Im. Next, coming to the average value of an alternating quantity. It is also defined as the mean value of the current or voltage. I take the mean value as 1 by pi. Instead of taking square of current, here I am taking only the mean value of current. So I'll take I. I is replaced by Im sin theta. So I replace I by Im sin theta. Im is constant. I will bring it outside. So I get Im by pi. So integration of sin theta is minus cos theta. So I write it as minus cos theta. Upper limit minus lower limit. So I write it as minus cos pi minus cos 0. Cos pi is written as minus 1. Minus of minus 1 is plus 1. Minus cos 0 is 1. Minus 1, I will write it here. Minus of minus 1 is plus 1. Plus 1 plus 1 is 2. So I get 2Im by pi. So this is how I get the average value. So let us define form factor. Form factor is defined as the ratio of the RMS value to average value. RMS value is Im by root 2. Average value is 2Im by pi. Im get cancelled, so you get pi divided by 2 root 2. So when we solve for pi divided by 2 root 2, we get to know that the form factor of a sinusoidal waveform is 1.11. Thank you for watching this video.